Hey guys, welcome to the video. This is Just Math Y'all, and we are going to look at systems of equations today. Okay, so now we are focusing on systems of equations in a nonlinear. Okay, now in Math 98, we do linear. So in your assignments, you've been posted those. Those have been posted for you to review. Some of the same exact methods and the same exact theory is behind the linear and nonlinear. So there's a lot of similarities here. So first of all, systems of equation is two or more equations with two or more variables. Okay, so if you have three variables, you need three equations. If you have four variables, you're going to need four equations. In these problems, we're only going to have two equations for the most of them. And two equations, we need two variables at minimum in order to solve for the points of intersection, because that's what it means to solve a system. We're finding the points that the equations have in common, and that is the points of intersection when it comes to graphing. Now, there's three ways to solve systems of linear equations that we will talk about. There are more than three ways to solve, but the ones we're going to talk about will use either graphing, elimination, or substitution. There are several other methods out there that are really fascinating to learn, but this is all we're doing today. So graphically, we're looking for the points of intersection. That's what we're looking for. And we may have more than one point of intersection. It depends on what we're dealing with. So for instance, these are nonlinear mixed in with some linear. We will have some linear. So just in generally, remember linear means line. So if I have two lines, they will intersect at most one point. But if I have a parabola and a line, I might have two solutions. I might have one depending on where that line actually intersects, but I could have two. We're also going to learn how to do a circle. So if I have a circle and a line, well then I'm going to have maybe two solutions. And if you did a parabola and a circle, you could have two solutions. Well, let me draw it differently. You could have more than two solutions if I could draw it correctly, but you could have more than two solutions. So depending on what we're dealing with, okay? We're going to do graphing. We're looking for the points of intersection. Same thing happens with substitution and elimination. They're just algebraic methods so that you don't actually see the graph and you don't actually see the points of intersection. And the points of intersection could be really ugly. They could be irrational numbers, or they could just be whole numbers, or they could just be rational numbers. They could be fractions, but there could be something that we're not used to looking at. So let's jump in. Okay, so for this first one, we have two equations. We have a quadratic equation, which is a parabola, and we have a linear, of course, which is a line. Now, we went over graphing parabolas at one point. You may or may not remember them, but we could just plot points, or we can do the vertex. For this one, I'm going to plot points to do my parabola. I'm just going to plot points to get this graph. I know what it's going to look like. I studied it. I know it's probably going to open up. And so just let's get a couple of points in here to get this good. If I x is 0, I'm going to get y is 4. So 0, 4 is here. I know it's going to open up. So if I do 1, if x is 1, I'm going to get 5. If x is negative 1, I'm also going to get 5. So I'm looking at a parabola that looks something like this. Okay? Now, this next picture is a line. This next one is a line. So for the line, I have y is equal to negative x plus 6. Now, if you remember how to graph lines, you can shortcut it. But again, probably most everybody doesn't remember, so I'm going to plot points. If I plug in 0 for x, I get 6 for y, so there's that one. If I plug in 1 for x, I'm going to get 5 for y. That's not right. There we go. We get 5 for y. And if I plug in -1 for x, I'm going to get 7. And if I plug in -2 for x, I'm going to get 6, 7, 8. I'm going to get 8. Okay, so I have this line that I'm going off the grid on. Something like that. And my parabola, I also have some points in my parabola that I didn't put in here. What if I had this one right here? -2 in my parabola, I'm going to get 8. So, sorry I didn't get that one in there. So there's my parabola. So we have 2 points that they share. So the 2 points that are shared are my solutions. And the first one is -2, 8. And the second one is 1, 5. So those are my solutions to this system of equations. Okay, let's look at another example. This time we have a circle and a line. All right, now I haven't taught you how to do a circle, so it's really easy. Well, not always really easy, but the ones that I'm going to do are going to have a center at 0, 0, and that's based on the fact that there's no numbers here. This is the center of my circle. And so that's not actually a point on my circle, but that's where it's centered. And then the 16, well, that is the radius of my circle squared. So that means the radius is 4. And so if I go 4 units from my center, right, left, 4 units up, and 4 units down, there's my circle. And then I connect my dots as a circle the best I can. I know it's not perfect, but there's my circle. So now my linear, my line, I have x plus 2y equal 10. Again, if you want to do it by plotting points, you can. It's a line. You don't need but 1 or 2. So I'll plug in if x is 0, if x is going to be 0, y is going to be 5. If x is 2, y is going to be 2 plus 2y equal 10. Y is going to be 4. So 0, 5 is a point. Let me do a different color for this one. So for my linear, 0, 5, 0, 5 is up here. And 2, 4 is here. And let's see, I think that's it. So I'm looking at a no solution here, which I don't believe is correct, but no solution because they don't intersect. If they do intersect, I don't know what point it is. So, all right, so this is what we're doing. Hope this helps. It's just math, y'all. You can do it.